Welcome to the DIY Honda Garage channel. The DTC B1193 refers to a communication issue specifically concerning the gauge control module of the Honda Accord 2023 and later models. This error arises when the gauge control module cannot receive signals from the steering switch via the local area network (LIN) bus system. The LIN is a communication protocol used for connecting various components within automotive systems, allowing for a simpler and more efficient exchange of information. In this scenario, the gauge control module identifies an abnormality in the signals it expects, resulting in the storage of the DTC. The gauge control module is crucial for providing data such as speed and fuel level to the driver, making its effective communication vital for the vehicle's operation. Without proper signals from the steering switch, the functionality of the gauge control module is compromised, leading to potential driver indication failures. The DTC B1193 indicates a breakdown in communication between the gauge control module and the steering switch. The gauge control module is responsible for interpreting various sensor inputs to provide the driver with accurate information about the vehicle's performance, including speed and fuel level. It is generally located behind the dashboard, connected to various vehicle systems via the LIN bus. The steering switch, which allows for user interaction with the vehicle's audio and information systems, is also a crucial component and is typically mounted on the steering wheel. If there is a communication breakdown, it suggests that either the connections, wiring, or the components themselves are defective. Understanding these components' roles and their connection points is essential for troubleshooting this DTC efficiently. Several factors could contribute to the triggering of DTC B1193. Firstly, a failure in the communication line, specifically the LIN bus that connects the gauge control module and the steering switch, may prevent the successful transfer of signals. This can arise from damaged wiring, bad connectors, or short circuits within the LIN circuit. Secondly, a faulty audio remote HFL hands-free link switch may also be responsible for the failure in communication. If this switch is defective or not functioning properly, it can lead to loss of signals. Finally, the gauge control module itself may be malfunctioning. If it has internal faults or is unable to process incoming signals, it will trigger this DTC, indicating a communication error. When DTC B1193 is triggered, there are several symptoms that drivers may notice. One prominent sign is inaccurate gauge readings on the dashboard, wherein the speedometer or fuel gauge fails to reflect actual vehicle conditions. Additionally, non-responsive steering controls may occur, impeding the driver's ability to manage audio settings and other operations connected through the steering switch. Furthermore, the illumination of warning lights can indicate that there is an issue with the gauge control system. These symptoms highlight the importance of the gauge control module's reliable functioning, as any failure can significantly impact the driving experience and safety. The first troubleshooting step for diagnosing the DTC B1193 involves turning the vehicle to the on mode and waiting for at least 4 seconds. This step is crucial as it allows the vehicle systems to boot up and initiate communication protocols within the LIN bus system. By doing so, it establishes a baseline communication readiness between the gauge control module and related components. Any interruptions or failures in this initial step may signify underlying issues with the vehicle's electrical system or communication links. It's important to ensure that all systems are operational before proceeding further into more intensive diagnostics. In this second troubleshooting step, focus shifts to inspecting the external circuit connections involved in the LIN bus system. Specifically, The circuit inspection should involve examining the audio remote HFL switch connections, as well as the ground GND connections associated with the gauge control module. The LIN bus involves several specific connections: the power supply line plus B option, the LIN communication line, LIN start switch, and the ground line. The inspection should confirm that these circuits have continuity and are free from corrosion or damage. If any issues are found in these connections, they should be repaired or replaced to restore communication integrity. The third step involves disconnecting the audio remote HFL switch to isolate the component and ensure that it is not the cause of the communication issue. After disconnection, it is essential to inspect the wiring associated with the switch for any visible faults, such as frayed wires, broken connectors, or damaged insulation. These types of faults can disrupt the integrity of the signal being sent to the gauge control module. If problems are detected during this inspection, they should be addressed before reconnecting the component. This step is vital, as a faulty audio remote switch could lead to misdiagnosed issues if not properly evaluated. In this penultimate troubleshooting step, replace the disconnected audio remote HFL switch with a known good component. This action is taken to determine whether the original switch is malfunctioning. By using a component that is confirmed to work, technicians can quickly assess whether the initial symptoms reappear. If the symptoms recur with the new switch, the problem likely lies elsewhere, such as in the wiring or the gauge control module itself. However, if the symptoms disappear, it indicates that the original audio remote switch was indeed the source of the issues. This test procedure is critical for efficient and accurate diagnosis. The final troubleshooting step focuses on the gauge control module itself. If previous inspections of the wiring and components do not reveal any faults, it is reasonable to conclude that the gauge control module is likely the cause of the DTC 1193. Inspect the gauge control module for any visible signs of damage, corrosion, or disconnection. It is important to perform these checks carefully, as a faulty gauge control module can lead to significant failures in vehicle information displays. If determined to be faulty, the gauge control module should be replaced with a new one, ensuring that all connections are properly established post-installation. After completing the necessary repairs associated with DTC B1193, it is critical to perform a final verification process. Start by clearing any DTC codes from the vehicle's memory through appropriate diagnostic tools. Following this step, recheck the system functionality by revisiting the operations that previously exhibited issues. This would include testing the gauge readings and the functionality of the audio remote HFL switch. Ensuring everything operates smoothly will confirm that the repairs made were successful and that the communication failure has been resolved. This verification step is essential for ensuring the long-term reliability of the vehicle's information systems. To prevent similar DTC B1193 issues from arising in the future, implementing a routine preventive maintenance program is highly recommended. Regular inspections of circuit connections related to the gauge control module and the audio remote HFL switch can help identify early signs of wear or damage. Ensuring that these connections are secure and free from corrosion can significantly enhance the reliability of communication systems within the vehicle. Moreover, routinely checking for any cracks or frays in wiring can prevent unexpected communication failures. This proactive approach not only helps maintain optimal vehicle performance, but also contributes to driver safety and comfort. In conclusion, understanding DTC B1193 provides vital insights into the health of the Honda Accord's complex communication systems. The significance of communication between the gauge control module and the steering switch cannot be overstated, as any disruption can compromise critical vehicle operations. The diagnostic steps outlined ensure a systematic approach to isolating and resolving the issue, from initial inspections to final verification checks. Following these procedures not only aids in effectively diagnosing the DTC, but also encourages practices that can prevent its recurrence. Overall, applying these troubleshooting techniques fosters reliability in vehicle performance and enhances overall driver safety. Please like and subscribe to the channel. See you next time.